So we're going to do our last day of arithmetic sequence, and it's a really short one. So your teacher might have also added in geometric sequence then with this too for today. So here we go with arithmetic sequencing. Given a term in arithmetic sequence, given a term in an arithmetic sequence and the common difference, find the first 5 terms and the explicit formula. Okay, now it's probably going to be easier to find the explicit formula first and then the first 5 terms. So that's what we're going to be doing right now. We're going to find that explicit formula. So what we need to remember is let's look at what we know. We know the formula. A sub n is equal to a sub 1 plus d times n minus 1. We know that. In order to find that explicit formula, we have to have a sub 1. We don't. Do we have d? Yes, we do. And here's the other thing that we have. We have a sub 32, which is 622. So what that tells us is that a sub n is a sub 32. Okay? A sub n is a sub 32. So that means n is equal to 32. So we have d, we have n, and because a sub n is a sub 32, a sub n is equal to 622. Okay? So we can find 2 bits of information from here, what term we're looking for and what that term is. So we're going to plug that information in. So here we go. A sub n, we're going to use the 622. A sub 1 is what we don't know. We know the difference that was given to us. And we figured out n was given to us also. It's 32. Now we're just going to solve this equation for a sub 1. Okay? So now we have 622 is equal to a sub 1 plus 20 times 31, which is 620. We subtract 620 from both sides, and we get 2 is equal to a sub 1. So we now have, whoops, sorry about that, we now have a sub 1. So that means we can write the explicit formula. A sub n is equal to a sub 1, which is 2, plus the difference, 20, times n minus 1. And we can also simplify that. We might want to simplify because if we're going to find the first 5 terms, it's much quicker if we can just plug it in. So we're going to simplify this. A sub n is equal to 2 plus 20n minus 20. A sub n is equal to 20n minus 18. Now you wouldn't have to do that. We're going to find the first 5 terms, so it's going to be much quicker if we do that. And we weren't left a lot of room for this, or maybe I just took too much. So here we go. I'm going to come up here, and I'm going to find a sub 1. Oh wait, we already know a sub 1. Hello, that's 2. We just found that. I'm going to find a sub 2 by plugging it in. So that's going to be 20 times 2 minus 18. See what I'm doing? I'm taking this explicit formula, and I'm going to plug in 2 because I want the second term. 40 minus 18, and we get 22. Our answer's going right down here. Okay, then we're going to find a sub 3. Sub 3. And we get 42. Okay, now, notice the other pattern that's happening here. This is where we might slip into our recursive formula. See how it's going to go up by 20 every time? So now that I see that, and I should have seen it anyway because the difference was 20, okay, I could just add 20 to this. And I can add 20 to this. And there's my first 5 terms. So it's kind of like you're using both. You could go all the way through and use explicit to find all 5 of them. Or you could kind of go, hey, wait, it's going to be a difference of 20 every time. I'm just going to do it that way. So on B, what I would recommend is try this one on your own. Go through and find your explicit formula and you'll find your first 5 terms. So if you want to watch me do it, here we go. We're going to write down the formula again. Okay, and we're going to plug in what we know. Remember, this is actually a sub n, and that means that this is n. Okay, so we have negative 162. That's our a sub n. A sub 1 we don't know. The difference they told us was -8. We know our n is 18 because they told us our 18th term was -166 by showing us this. Now we're just going to solve this for a sub 1. Pull out your calculators. Multiply -8 times 17. Get -136. We're going to add 136. And we get a sub 1 is equal to -30. Okay? If that is our a sub 1, so that means that our explicit formula is a sub n is equal to 30 plus -8 times n minus 1. And we could have written this as -8. Either one is fine. Now I'm going to simplify that so I can use that to use my first 5 terms. Or we could just go back to our recursive, taking our first term and keep on subtracting 8. Might not be a bad idea. So one option is we know that our first term is -30. We're going to find our next 5. We have 2 options. We could go through and do 4 times, find a sub 1, find a sub 2, okay, plug it in. That'd be 30. Oh, hey, wait, let's simplify this before I go any further. So we have 30 plus -n plus 8. So that is -8n plus 38. Why do I keep on messing up on that? Because I keep on doing that negative. I drop a negative. So, and it's kind of hard to see. So let me write it again. -30, -30, -30. And then this is going to be plus 8. So that's going to give me a -22. This is my simplified form of my explicit formula. Now I can find a sub 1 is already given. A sub 2, I can just plug it in. And I get -16 plus -22, which of course is going to give me a -38. That is my next term. Okay. I could then find a sub 3, or I could just keep subtracting 8 here. So take -38, that's my second term, subtract 8, that gives me a -46. So just go with whatever your mind sees. I tend to do this because I like an exact way, but it doesn't really matter. And now I'm doing this one for some reason. So -54, we're up to 4, we need one more. So we're going to subtract another -8, and we get -62. There's our first 5 terms. Oh, remember, this is just the first 5. There's more after that. Okay, application of arithmetic sequence in the real world. After knee surgery, your trainer tells you to return to your jogging program. He suggests jogging for 12 minutes each week for the first week. Each week thereafter, he suggests you increase the time by 6 minutes. How many weeks will it be before you are jogging 60 minutes per day? So in our last notes, we had a table, and if you want to do that, it might make it a little easier to see. We have week 1, week 2, and so forth. And he suggests jogging for 12 minutes each week for the first week. And then each week he increases it by 6. Okay? That table might be helpful to see where this information is coming from. So you can always make a table as to what's going on. A sub 1 we know is 12 because 1 is the first week. That's the first week. What's the difference every time? They told us that too, 6 minutes. They also told us that by the end of all this time, we want to be jogging 60 minutes each week. So we're going to go through all this stuff and we're going to get 60 minutes. So that means a sub n is actually 60. That's going to be our nth term. That's our nth term. So what we're trying to find is how many weeks. That is n. That's what we're trying to find out. So let's plug it into our explicit formula. So a sub n we know, that's 60. We know a sub 1, that's 12. We know the difference is 6. We don't know n. That's what we're going to find. So now let's solve this equation. Combine like terms. So, sorry, That should be a plus sign. 18 plus 6n, subtract 18. We get 6n is equal to, where did I get 18? Oh, do you see my mistake? I added. I was going too fast, not paying attention. That's a 6. We're going to subtract 6 from both sides. We get 54. Divide by 6. And we get 9 is equal to n. Oops, you want to see the whole thing. So what does that mean? Well, what were they asking for? How many weeks? So in 9 weeks, you can run 60 minutes per week. Okay, so that's what they were looking for. You'd be able to run 60 minutes. Now, on the back is some more about arithmetic sequences, and it's some cool problems. We're not going to do them right now, but it's some interesting stuff, and if we have some time extra in class, I'd be happy to show those to you if you want to come in and see that. We'll also revisit it after we do what's called systems of equations. Okay, good. Let's look at your homework. On your homework, you're going to be doing the same things we were doing in class. You just get more practice on it. And we're not going to do this page because we didn't do those notes. Good. Okay. If you have any questions, you know where to find us. Thank you very much.